Hi guys, this is Lisa Knight. I'm your instructor and this is your Module 2 feedback video. The first thing I'm going to do is I'm going to talk about Homework 1. First of all, if you are having problems with the math, you have to get a tutor or you have to contact me so that we can meet online and have help sessions. I tried to send out a survey last week, but I only got 3 responses. And it was obvious the responses were from people who didn't need help. So there are enough of you in here that are having problems that I really want to offer you help, but I can't do that unless I know, that you need it and that you're willing to meet me online to get help. Otherwise, I know that there is a tutor available, and I would contact that tutor via academic assistance at Brunswick. All right, so for your homework, this was not meant to be a super hard worksheet. It was meant to kind of get you to tell me the difference between distance, displacement, velocity, and speed, and to learn how to use, or show me that you could use the kinematics equations. So first of all, remember that the kinematics equations are for objects that are accelerating. So if the object is getting faster or slower, then you will use one of the kinematics equations to solve a problem. If not, you're just using speed equals distance over time or velocity equals displacement over time. So most people understood that displacement was the total distance of an object. Distance was a total sum of the distances, but displacement was the change in position. And so you had to assign a direction to be north and one to be south. North is positive and south is negative. So when you add 5 to -10, you would get a displacement of -5 meters. One thing that some people are consistently doing is they are not giving units. You need to show units and you need to show your calculations. If you do not show your calculations, I will not grade the problem. If you show me some kind of calculation and you do it completely wrong, at least I can give you a point for showing me something. To find the average speed, you just take your distance and divide it by your time. Make sure that you convert your units to standard units, meters per second. We always keep our units in meters and seconds and kilograms. Those are the standard units in physics, as we learned in chapter 1 in the very first video that I made myself for you. So make sure that you do that. So, and also make sure that you follow the significant digit rule for the worksheet, which for this one said to 3 sigdigs. So you should have had 1.04 e to the -3 meters per second and -3.47 e to the -4 meters per second. All right. In number 2, this was probably the toughest one because it had 2 different types of motion going on. First, you had a car traveling at constant speed for 7 seconds. So conceptually, you need to conceptualize this. The car is moving 20 meters per second every second for 7 seconds. So the distance it travels is easy. It's just 20 times 7, right? 20 meters for every second. There's 7 seconds. So 20 times 7 is 140 meters. Then it comes to a stop. So its initial speed is 20 meters per second. The time that it does come to a stop is 3 seconds. Some of you put in 10 seconds because it wasn't accelerating the whole way. And then it comes to a stop. So that's the final speed. So because it's accelerating and we're looking for acceleration, then we're going to use a kinematics formula. So I have VF, VI, and I have T. And the only formula I can use is VF equals VI plus AT. So A is equal to -6.67 meters per second squared. Okay, so we know that the distance that it traveled at constant speed was 140 meters. The distance that it travels accelerating is going to be found with a kinemax equation as well. So what do I know? Well, I know that it starts with a VI of 20 meters per second, and it comes to a stop. So its VF is 0. I know that it does that in 3 seconds, and I'm looking for X. So the only formula I have that works for that is VF squared equals VI squared plus 2AX. So a lot of you are concerned about picking out the right formula. So when I look at this list, what I actually, sorry, that's the wrong formula. Why is that the wrong? Well, I could use this formula, but the problem is that if I use it, I have to use my A. And if I calculated my A wrong, then it's going to be wrong too. What I need, if you look at this list here, actually, I have a VF, a VI, a T, and an X. What's completely missing, other than the fact that I did calculate it, but I don't want to use a calculated value, is an A. So I need to pick a formula that has no A in it. So each one of the kinemax formulas is missing one of the variables. It might be missing T, it might be missing X, it might be missing A. In any case, what you want to do is find the formula that is missing that one piece of information that your problem doesn't give you. So this formula would be X equals 1/2 of VI plus VF times T. So if I do that, 1/2 of VI is 20 plus 0, so 1/2 of 20 times 3 seconds, and that only turns out to be 30 meters. If I add those together, I get a total distance of 170 meters. All right, in number 3, we're going to use a kinemax equation. So if I list what I know, this is what I know. I know that the plane is traveling at 100 meters per second, so that's VI. I know that it's going to come to a stop, so VF is 0. I know that he does it in 10 seconds, and I want to know how long the driveway is. So once again, I need a formula that has VF, VI, T, and X in it, and that happens to be the same formula that I used above. And I should get 350 meters as my answer. In number 4, I'm starting, so I've got my bullet here, and it's gonna start in the barrel. So it's gonna start from 0, and when it leaves the barrel, it travels 45 centimeters, and it comes out with a final speed of 125 meters. So if I list what I know that VI is 0. Ooh, that's too little. Sorry. Let me turn off my, there we go. VI is 0. I know that VF is 125 meters per second. I know that X is 45 centimeters, but I can't leave it as that because everything has to be in standard units when I use these formulas. 0.45 meters. And I know that I'm looking for A. So I need a formula that doesn't have time in it, right? I need one that has VI, VF, X, and A. And the only formula that has that is this formula here. And so I'm going to rearrange that equation, and I'm going to get 17,361 meters per second squared, but I need to round that to 3 sigdigs. So it should be 17,400 meters per second squared. In number 5, we're going to answer some questions about a position graph. So the slope on a position graph is always the velocity. The time that it's at rest is where it's staying at the same position. So it stays at the same position from 10 to 15 seconds. And it's at rest at t equals 40 seconds too. It just stops. Which time interval does it have a constant velocity backwards? Well, it starts at 60 meters away from its start point here at 0, and it goes back to 0, and it keeps going back. So all this time here from 15 to 40 seconds is when it's going backwards. And then the last thing that you're supposed to answer is what is that slope? And that slope, I just found the slope of that line and it was -4 meters per second. It's a negative sloping line, so you should have a negative slope. And I ask you how to find instantaneous velocity. It is the slope of the line tangent at that instant. In number 6, we're looking at a velocity graph. The slope of a velocity graph is acceleration, and the area under the curve is the displacement. It's accelerating from 0 to 2 seconds and from 10 seconds to 12 seconds. And it's traveling at constant speed from 2 seconds to 10 seconds and from 12 seconds to 16 seconds. And then the last thing you have to do is you have to find the displacement, which is literally the area under the curve. So if I do that, what I want to do is I want to break this up into shapes. So this shape here, right here, would be a triangle, and 1/2 of 2 times 8 would be 8. And then this is a big rectangle here. So this huge rectangle here is the length, which is from 2 to 10. So that's 8 times 8, which is 64. So I'd add those two together. And then this is a little more confusing here because I have two shapes. First, I would find the area of this little rectangle. So 1/2 of 2 times 4 would be 4. And then I would find the area of this little rectangle, which would be 2 times 4, which would be 8. So I've got 4 and 64 and 2 and 8. And then finally, I have this here, which is 4 times 4, which is 16. And when you add all of those areas up, you get an area of 100 meters. And I've shown you the work here for that. So it's really not that hard to use these graphs, but you do have to memorize how to use each type of graph. All right, so I'm going to load this up in the Module 2 so that you'll have that rubric so you'll know how I graded things. But once again, if you did not show all your work, I did not give you credit. Answers don't cut it for me. I don't know what you did to get that answer. And the instructions are very clear that you need to show your work and you need to show your equations and you need to show your units. And I would like you to round your answers to 3 sigdigs. I may at some point say I want you to round them to 2 sigdigs. So make sure that you are following those directions as you are instructed. Please email if you have questions. The last thing I want to talk about is the discussion forum. So I was kind of lenient on the discussion forums. The purpose of the discussion forum is not to talk about how hard physics is. The purpose of the discussion forum is for you to actually have a place to post questions that your problems, which means that you have to work ahead of time. You are going to have to, and you are expected to, do the reading and watch the videos and start to look at your homework worksheet before you make your initial post. So that very first week, you need to be preparing and studying, and then you need to start looking at your homework. And then I've changed it this week so that what I want you to do, so that I'm being very specific here, is I want you in your initial post to describe one specific question you're having on the problems on the worksheet that's due this week. And if you don't have any problems on the worksheet, then you need to discuss a problem from the reading assignment. So you're going to discuss one specific problem. So I want you to post a question, the actual question, and then I want you to give a description of how you're going to solve it, or if you're confused about a specific thing, I want you to try to give some specific constructive information about what you're having problems with. Then when I go and read those initial posts, I can give you feedback and maybe start you off. Then I want you guys to respond constructively during the next week to at least 2 different classmates. And if that means that you're going to say, oh yeah, this is how I ended up doing the problem, and show them how to do it, that's fine. But you need to make sure that you guys are being very specific and utilizing this forum to actually learn something. This is not a place for you to talk about how hard it is, how you can't do the work. This is because that's not, I know this hard. I know physics is hard and I want to help you, but I can't help you if I don't know what is hard for you. And I'm trying to pinpoint specific examples so that I can go from there and help you. So if you guys would please participate in the discussion, make sure that you've posted on 3 separate days. The first post needs to be done this week by the 5th, and then the next 2 on 2 other days. And then next week I will post and give you more information about the lab assignment. I will say that the gist of this lab was that you knew that the only way for you to have the same average speed and average velocity is if the object's moving in one direction, because the distance and the displacement have the same numerical value. That's what magnitude is. It's just a numerical value. There's no mystery to the word magnitude. And then the other point of the lab was that if the average velocity and average speed are different, it is because the object has changed direction, because now the distance is different than the displacement value. But that's the main point. And I've made comments on your labs and your homework, so you can look at those when you click on your grades in the grade book. So please email me if you have any questions, and let's get started and have a great week.